October 29th, 2025. While the world was waiting for NASA to release data from the Mars orbiters, something unexpected happened. Something that changed the entire conversation around 3I-ATLAS. The China National Space Administration issued a statement. Not a routine observation report. Not a scientific paper. A warning. And here's what makes this absolutely unprecedented. China doesn't issue warnings about space objects. They observe. They analyze. They publish findings in academic journals months or years later. But this was different. The statement was brief, technical, and carefully worded. But buried in the language of orbital mechanics and trajectory analysis was something that made every space agency on Earth sit up and take notice. China's Deep Space Network had detected anomalous velocity changes in 3I-ATLAS. Changes that couldn't be explained by gravitational forces alone. Changes that suggested, and I'm quoting directly here, non-gravitational acceleration inconsistent with known cometary outgassing patterns. In plain English, Atlas is maneuvering, and nobody knows why. While NASA remains silent, China just told the world that this interstellar visitor might be under some form of control. Let me walk you through what happened, why it matters, and why NASA's continued silence is now more troubling than ever. First, let's understand what China actually detected. The China National Space Administration operates a network of deep space tracking stations, massive radio dishes spread across the country that monitor everything from lunar missions to distant spacecraft. These aren't small installations. We're talking about dishes that are 40 to 70 meters in diameter, equipped with some of the most sensitive receivers on the planet. The main facility in Kashgar, in western China, can detect signals from spacecraft billions of kilometers away. But they also track asteroids, comets, and other solar system objects. It's routine work, unglamorous, the kind of thing that rarely makes headlines. These tracking stations use a technique called radio interferometry. Multiple dishes observe the same object simultaneously, and by comparing the signals, they can determine position and velocity with extraordinary precision. We're talking about accuracy measured in fractions of an arcsecond. That's less than 1,000th of a degree. Except on October 26th, when analysts at the Beijing Aerospace Control Center noticed something strange in the tracking data for 3I-ATLAS. The object's velocity had changed. Not dramatically. We're talking about changes measured in centimeters per second. But measurably, definitively, and most importantly, consistently across multiple observation sessions. Now, velocity changes aren't unusual for comets. They outgas. Material jets away from the surface, creating tiny amounts of thrust that nudge the object off its predicted path. We've seen this countless times with solar system comets. It's called the rocket effect, and it's well understood. When Halley's Comet makes its rounds through the inner solar system, it can deviate from its predicted orbit by thousands of kilometers due to outgassing. Scientists routinely account for this when calculating comet trajectories. But here's the problem. The velocity change China detected didn't match the expected pattern for cometary outgassing. Normal outgassing is chaotic. It happens when sunlight heats volatile ices on the comet's surface, causing them to sublimate explosively. Different parts of the surface heat up at different times as the comet rotates. The thrust is uneven, unpredictable, and varies with the object's rotation and position relative to the sun. If you plot the acceleration of a typical outgassing comet over time, it looks like a jagged, irregular line. Spikes when a particularly icy patch gets heated. Valleys when the rotation moves that area away from the sun. No pattern. No predictability. What China detected was different. The acceleration was smooth, sustained, and, most disturbingly, it appeared to be directional. Not random jets firing as the object tumbled through space, but consistent thrust in a specific direction, maintained over hours at a time. That's not how comets behave. That's how spacecraft behave when they fire their thrusters. The Chinese statement was released through official channels, the CNSA website, and state media outlets. But it wasn't front-page news. It was buried in technical bulletins, written in the dry language of orbital mechanics that only specialists would read. The statement was titled Observation Report on Non-Gravitational Perturbations in Object 3I-ATLAS. Not exactly clickbait. Most people missed it entirely. It didn't. Theory 2. China is pressuring NASA to release data. This is the more cynical interpretation, but it might also be the most accurate. Remember, NASA has been sitting on Mars orbital data for over 2 weeks now. Data that almost certainly shows the same anomalies China is reporting, probably in even greater detail given the proximity of the Mars orbiters to Atlas during its flyby. By going public, China forces NASA's hand. They can't stay silent forever while another space agency is making claims about an object NASA has better data on. It's a diplomatic chess move. Force transparency by making silence untenable. If NASA continues to withhold data while China is publishing warnings, it makes NASA look either incompetent, like they missed something obvious, or secretive, like they're deliberately hiding information. Neither is a good look for an agency that prides itself on scientific openness and public engagement. China's statement essentially says, we're being transparent. We're sharing what we found. What's NASA's excuse for staying quiet? It's brilliant strategy. Make your opponent's caution look like a cover-up. Theory 3. China genuinely believes this is a potential threat. This is the darkest interpretation, but we can't dismiss it. What if China's analysis suggests that Atlas's trajectory changes aren't random? What if their models show the object making course corrections that seem deliberate? If you believe, even hypothetically, that an interstellar object might be exhibiting signs of control, issuing a warning becomes a matter of planetary security. Think about the protocols we have for near-Earth asteroids that might pose an impact threat. When astronomers detect an object on a potentially hazardous trajectory, they don't wait for perfect data before raising the alarm. They warn immediately, then refine the calculations as more observations come in. China might be applying the same logic here. If there's even a chance that Atlas is something other than a natural object, the responsible thing to do is issue a warning while continuing to study it. You don't stay quiet about potential threats just because the data is ambiguous. You alert the international community and let everyone work together to figure out what's happening. Of course, this raises the uncomfortable question. If Atlas isn't heading toward Earth, and it's not, what kind of threat could it pose? Maybe not a physical threat, but a threat to our understanding of what's possible in the universe. A threat to the assumption that we're alone. A threat to the frameworks we use to interpret reality itself. Those kinds of threats might not destroy cities, but they can reshape civilizations. Now let's talk about what NASA hasn't said, because their silence at this point is deafening, and it's starting to feel calculated. China issues a statement about anomalous acceleration. NASA says nothing. Independent observatories around the world confirm trajectory deviations. NASA says nothing. The global astronomy community erupts in debate about non-gravitational forces and what they might mean. NASA says nothing. Amateur astronomers start posting tracking data on forums, showing the discrepancies between predicted and observed positions. NASA says nothing. The official line remains unchanged. Data analysis ongoing. Full release pending peer review. No timeline. No preview images. No preliminary findings. Just silence. But here's what's happening behind the scenes, according to sources within the planetary science community who spoke to me on condition of anonymity. NASA is locked in intense internal debate. And I mean intense. We're talking about meetings that run until 2 in the morning. Scientists shouting at each other in teleconferences. Email threads with hundreds of messages debating what to do. One faction wants to release everything immediately. Show the world the Mars orbital images, the spectral data, the trajectory analysis. Let the scientific community examine it all and reach their own conclusions. Their argument is straightforward. This is how science is supposed to work. You gather data, you publish it, and you let peer review sort out the interpretations. Holding data back undermines public trust and makes it look like you have something to hide. Another faction urges extreme caution. They argue that releasing ambiguous data will trigger mass speculation, conspiracy theories, and public panic. Better to understand it fully, to have a coherent explanation ready before going public. Their concern is legitimate. We've seen what happens when incomplete scientific information gets released into the wild. Remember the faster-than-light neutrinos that turned out to be a loose cable? Or the arsenic-based life forms that turned out to be contamination? Scientific credibility takes years to build and moments to destroy. And then there's a third faction, and this is the really interesting one, that believes the data shows something so anomalous that standard peer review isn't sufficient. They want to brief government officials first, consult with defense departments, establish protocols for information release, maybe even coordinate with international partners before any public announcement. This faction argues that if Atlas really is exhibiting signs of control behavior, this isn't just a scientific discovery. It's a matter of national, possibly planetary, security. The kind of thing that requires careful coordination at the highest levels. That third faction, they're not fringe conspiracy theorists. They're senior scientists with decades of experience. People who worked on classified projects. People who understand the intersection of science and national security. And the fact that they're calling for government briefings before scientific publication should tell you something about what they think they're looking at. Let me read you something that was leaked from an internal NASA memo. I received this from a source I trust, but I can't verify its authenticity independently. You'll have to judge that for yourself. But here's what it said. The object designated 3I. Atlas exhibits behavioral characteristics inconsistent with natural cometary or asteroidal bodies. Observed non-gravitational acceleration exceeds plausible outgassing models by a factor of 3 to 7, depending on assumed mass and composition. Trajectory corrections appear non-random with statistical significance p less than 0.001. Energy requirements for observed acceleration patterns suggest internal heat source of unknown origin. Spectral anomalies remain unexplained. Recommend escalation to planetary defense protocols pending further analysis. Suggest coordination with DoD and intelligence community before public data release. Let's unpack that. Non-gravitational acceleration exceeds plausible outgassing models by a factor of 3 to 7. That means the thrust being generated is 3 to 7 times stronger than what could be produced by normal cometary outgassing, even under the most generous assumptions. Trajectory corrections appear non-random with statistical significance p less than 0.001. In statistics, p less than 0.001 means there's less than a 0.1% chance that the pattern is due to random chance. That's about as close to this is definitely real as statistics ever gets. Energy requirements suggest internal heat source of unknown origin. This is the part that should make everyone pause. Whatever is causing the acceleration requires energy. A lot of energy, more than solar heating can provide, which means there's something inside Atlas generating heat, and we don't know what it is. Recommend escalation to planetary defense protocols. This is NASA speak for we think this might be a threat. Planetary defense protocols are the procedures NASA follows when an object might pose a danger to Earth. Protocols for tracking potentially hazardous asteroids, for calculating impact probabilities, for coordinating international response, for briefing government officials. If that memo is real, and I emphasize if, it means someone at NASA thinks Atlas might be more than just a scientific curiosity. It means they're treating it as a potential threat. The last line is particularly telling. Suggest coordination with DoD and intelligence community before public data release. DoD is the Department of Defense. The intelligence community means agencies like the CIA and NSA. Why would NASA want to brief the military and intelligence agencies about an interstellar comet? Unless they don't think it's just a comet. But here's the thing that keeps me up at night, and it should keep you up too. Atlas isn't heading toward Earth. Its trajectory takes it back out of the solar system. By early 2026, it'll be beyond Mars's orbit, heading for the outer planets and eventually interstellar space again. So if NASA is invoking planetary defense protocols, it's not because they think it's going to hit us. It's because they don't understand what it is or what it's doing. And when you don't understand an object that's exhibiting signs of control, even hypothetical, maybe we're misinterpreting the data signs of control. You treat it as a potential threat until proven otherwise. That's just prudent risk management. It's the same reason you call the bomb squad when you find an unidentified package at an airport, even though it's probably just someone's forgotten luggage. But it also reveals something crucial about what the data must show, because NASA doesn't invoke planetary defense protocols lightly. The bureaucratic threshold for activating those procedures is high. You need senior leadership approval. You need documentation. You need justification, which means the anomalies must be significant, reproducible across multiple instruments and observation sessions, and unexplainable through conventional models. It means that smart, careful scientists who've spent their entire careers studying comets and asteroids have looked at this data and said, this doesn't fit. We need help understanding this, and we need to be prepared for whatever the answer turns out to be. So what exactly is China warning us about? The official statement mentioned non-gravitational acceleration, but there's more in the technical appendix that most people didn't read. And frankly, that most people couldn't understand without a background in orbital mechanics. China's tracking data showed 3 distinct acceleration events over a 10-day period, each lasting approximately 6 to 8 hours, each producing velocity changes of 2 to 4 centimeters per second. That might not sound like much. 2 to 4 centimeters per second is slower than a leisurely walk. But over weeks and months, those small changes add up. They can alter an object's trajectory by thousands of kilometers. More importantly, the timing of these events is suspicious. And by suspicious, I mean statistically unlikely to be coincidental. The first acceleration occurred just after Atlas's closest approach to Mars. Specifically, about 4 hours after periapsis, the point of closest approach. The second happened as it crossed into optimal observation range from Earth-based telescopes, right when it should have been most visible to our best instruments. The third occurred just as it was about to move behind the Sun from Earth's perspective, entering a 5-week period where direct observation would be nearly impossible. Now it's possible, maybe even likely, that these are just coincidences, random outgassing events that happen to occur at interesting times. Space is full of coincidences. Sometimes asteroids pass close to Earth on significant dates. Sometimes comets brighten unexpectedly just when they're most observable. It happens. But the timing here is, let's say, convenient. Almost too convenient. If you were an intelligent entity piloting an interstellar probe through our solar system, when would you make course corrections? You'd probably do it right after your closest approach to major planets, when gravitational perturbations are strongest and small trajectory adjustments have the biggest effect. You might do it when you're most observable from the system's inhabited planet, to see if anyone notices or responds. And you might do it right before entering an observation blackout period, when no one can watch what you do next. That's exactly what Atlas did. I know how that sounds. I know it veers dangerously close to speculation that isn't supported by hard evidence. But China's warning wasn't speculative. It was based on measured data. Trajectory deviations that violate gravitational predictions with statistical significance that's hard to dismiss. And if those deviations are real, and multiple independent observatories say they are, we need to explain them. We need to explain why an interstellar object is accelerating in ways that don't match any natural process we understand. We need to explain why the timing of these accelerations seems to correlate with significant events in its passage through our solar system. And we need to do it with science, not wishful thinking or assumptions about what's possible. Here's what we know can cause non-gravitational acceleration in space objects, and why none of them quite fit. Outgassing. The most common explanation for cometary acceleration. When volatile ices sublimate, they jet away from the surface, creating thrust. But here's the problem. Outgassing is inefficient. You need to eject a lot of mass to create a little thrust. And Atlas's spectral signature suggests it's unusually depleted in the volatile ices that would produce strong outgassing. Plus, outgassing thrust is chaotic and irregular. What China detected was smooth and directional. That's not how outgassing works unless there's some mechanism focusing and controlling it, which raises more questions than it answers. Solar radiation pressure. Photons from the sun carry momentum. When they hit an object, they push it. This effect is well understood and is actually used to sail spacecraft using solar sails. But solar radiation pressure is weak, really weak. It works on lightweight objects with large surface areas, things like solar sails or Gossamer Comet dust. ATLAS appears to be massive. Estimates range from millions to billions of tons depending on composition assumptions. Solar radiation pressure couldn't account for the observed acceleration on something that massive. Yarkovsky effect. This is a subtle but real effect where thermal radiation from a rotating object creates thrust. The side that's been heated by the sun radiates infrared photons. Those photons carry momentum. Over time, this creates a tiny but measurable acceleration. We use Yarkovsky effect calculations to predict asteroid orbits over centuries. It's real physics, but it produces very small, very gradual changes. We're talking about orbital shifts measured in meters per year, not centimeters per second. And it doesn't produce discrete acceleration events lasting 6 to 8 hours. It's a constant, steady effect. Magnetic interaction with the solar wind. The solar wind carries magnetic fields. If ATLAS has a strong magnetic field of its own, interaction between the two could create forces. But this requires very specific conditions. You need a strong, stable magnetic field on the object. You need the right alignment with the solar wind. And even then, the forces are typically small. Plus, magnetic interactions would vary dramatically with solar wind conditions, which fluctuate constantly. They wouldn't produce the consistent, repeatable acceleration pattern China observed. Fragmentation and recoil. If large pieces break off ATLAS, the recoil could produce acceleration, like a rocket in reverse. But fragmentation events are visible. We'd see brightening as fresh ice is exposed. We'd see debris trails. We'd see changes in the light curve as the object's shape changes. None of that has been observed. If anything, ATLAS has been remarkably stable throughout its passage. Tidal forces from gravitational stress. When an object passes close to a massive body like Mars, gravitational stress can cause internal shifting or even cracking. This could, in theory, release stored energy or trigger outgassing. But again, this wouldn't produce the observed pattern. Tidal effects are strongest at closest approach and fade rapidly with distance. They don't produce discrete acceleration events hours after periapsis or weeks later as the object moves away. Every natural explanation has problems. None of them fit cleanly with all the observed data. None of them explain the timing. None of them explain the consistency. None of them explain the energy requirements. Which leaves us with an uncomfortable question. What if there isn't a natural explanation? What if we're seeing something that doesn't fit our categories because it doesn't belong in our categories? Let's be very careful here, very precise with our language. The data suggests non-gravitational acceleration. That's a fact, or as close to fact as observational astronomy gets. Multiple independent sources have confirmed it. The data could suggest controlled maneuvering. That's a hypothesis, one that fits the observations but isn't proven. The data does not prove artificial origin. That would be an extraordinary claim requiring extraordinary evidence, which we don't yet have. But here's what's undeniable. The accumulation of anomalies is getting harder to ignore. Let me list them for you. 1. The spectral signature that doesn't match any known comet. Carbon dioxide-rich, water-poor, with inverted metal ratios never seen in natural objects. 2. The anti-tail pointing toward the sun. A jet of metallic vapor that overcomes solar radiation pressure, something that requires significant energy. 3. The trajectory that's too stable. Active comets show perturbations from asymmetric outgassing. ATLAS doesn't. It moves like a dead rock while showing signs of activity. That's contradictory. 4. The green flash observed by Perseverance. A glow that requires carbon chemistry, but spectral data shows almost no carbon compounds. The light is forbidden by the object's own composition. 5. the trajectory alignment with the WOW signal coordinates. When you trace its path backward through space and time, it passes through the region where that famous radio signal originated. Odds of coincidence, less than 1%. 6. The measurable non-gravitational acceleration that can't be explained by known natural processes. Smooth, directional, occurring at strategically significant times. Each anomaly individually could be dismissed. Random chance, measurement error, incomplete models, unknown natural processes. But together they form a pattern. And patterns demand explanation. Scientists are pattern recognition machines. That's literally what we do. We look at data, we find patterns, we build models to explain those patterns. And right now, the pattern forming around 3I-ATLAS doesn't fit our natural models. It's not one thing. It's not two things. It's 6 independent anomalies, each of which is unlikely, all occurring in the same object. Statisticians have a concept called compounding improbability. When you have multiple unlikely things happening together, you multiply the probabilities to get the overall likelihood. If each anomaly has a 10% chance of occurring naturally, and you have 6 of them, the probability of all 6 occurring together by chance is 0.0001%. 1 in a million. At what point do we stop saying, that's improbable, and start saying, maybe our assumptions are wrong? China's warning isn't just about the acceleration. It's about the pattern, the accumulation of evidence that Atlas isn't behaving the way natural interstellar objects should behave. And their decision to go public, to issue an official warning rather than quietly publishing in a journal months later, suggests they believe this pattern is significant enough to warrant immediate international attention. China isn't prone to scientific sensationalism. Their space program is methodical, careful, and conservative in its claims. When they landed on the far side of the moon, they didn't hype it beforehand. They did it, then announced it afterward with engineering data to back it up. For them to issue a warning based on preliminary observations suggests they view this as genuinely important. Not a curiosity, not an interesting puzzle, but something that requires the world attention right now. So why is NASA still silent? I think, and this is informed speculation based on conversations with people in the field, that NASA is facing an impossible choice. If they confirm China's findings without offering a natural explanation, they legitimize concerns about Atlas's anomalous behavior. They open the door to questions they can't yet answer. They invite speculation about origins, intentions, and implications that could spiral into public panic or policy chaos. Imagine the headlines. NASA confirms. Interstellar object shows signs of control. Even if NASA added careful caveats, but it might be a natural process we don't understand yet. Those caveats would be ignored. The story would take on a life of its own. But if they deny or downplay China's findings without releasing their own data, they look like they're hiding something. They damage their credibility. They feed conspiracy theories. They let China shape the narrative unchallenged. So they're stuck, paralyzed between two bad options. And while they deliberate, China is shaping the global conversation, establishing themselves as the agency willing to speak truth even when it's uncomfortable, positioning themselves as more transparent than NASA. It's a masterclass in space policy and public communication. And NASA is losing. Every day that passes without a NASA response makes their eventual statement less credible. If you wait 3 weeks to reply, it looks like you're crafting a careful spin rather than sharing straightforward facts. Here's what happens next, and why it matters more than anything else in this story. Atlas is currently moving behind the sun from Earth's perspective. For the next 5 weeks, direct observation will be nearly impossible. The sun's overwhelming brightness and radio interference make tracking difficult or impossible. It's a natural blackout, a cosmic intermission where we simply can't watch what happens. But when Atlas emerges in early December, around the 5th or 6th, depending on observation geometry, every major telescope on Earth will be watching. Not just NASA and China, but the European Space Agency, Japan's space program, India's observatories, Russia's tracking stations, private observatories, university research groups, and thousands of amateur astronomers with sophisticated equipment. It will be the most observed interstellar object in history. Everyone will be looking. Everyone will be measuring. Everyone will be analyzing. If the acceleration continues, it will be detected immediately by multiple independent observers. There will be no ambiguity, no possibility of dismissing it as instrument error or processing artifacts. If it stops, if Atlas suddenly returns to purely gravitational motion, that's almost more interesting, because it would suggest the acceleration was temporary, situation-specific, or purposefully ended. Why would natural outgassing suddenly stop completely? That would be its own anomaly requiring explanation. We'll also get new spectral data from ground-based telescopes and space-based instruments. Better resolution than the preliminary observations. Multiple wavelengths. Detailed composition analysis. We'll get better images. The James Webb Space Telescope has been allocated observation time. So has Hubble. Multiple ground-based observatories with adaptive optic systems are scheduling time. If Atlas has any structural features, regular geometry, surface patterns, anything that looks designed rather than random, we'll see it. We'll get more trajectory measurements, enough data points to map any acceleration patterns precisely, to determine if they're periodic, responsive, or random. But here's what I'm watching for specifically, and what I think will be the smoking gun one way or another. Does the acceleration pattern repeat? If we see the same discrete acceleration events on a predictable schedule, say, every 72 hours, or synchronized with rotation period, or triggered by solar distance changes, that would be extremely difficult to explain naturally. Repetition implies mechanism. Mechanism implies structure. Structure implies either exotic natural processes or something designed. Does the trajectory change in ways that seem responsive? If Atlas makes course corrections that appear to optimize its path for specific objectives, like adjusting to remain observable from Earth, or avoiding certain regions of space, or heading towards specific targets, that would be profoundly unsettling. Natural objects don't navigate. They fall along gravitational curves modified by random forces. Navigation implies intent. Does it emit any signals we can detect? Radio, optical, infrared, anything. Because if an object is maneuvering, it might also be communicating. Or at least, we should be listening in case it is. Multiple radio observatories are already planning to point their dishes at Atlas when it emerges. The Search for Extraterrestrial Intelligence Institute, China's 500-meter aperture spherical telescope, the Allen Telescope Array, and others. They'll be listening across a wide range of frequencies, looking for any signal that seems structured, modulated, or information-bearing. If Atlas transmits anything, even briefly, even weakly, we'll detect it. And if it does, that changes everything. Let me end with this, because I think it's important to be clear about what we're really discussing here. I don't know what 3I-ATLAS is. Nobody does. Not yet. But I know this. China's warning changes the game entirely. It transforms Atlas from a scientific curiosity, just another interstellar rock passing through, into something that demands serious attention. It transforms the question from what interesting science can we learn to what are we actually looking at. If it's natural, some exotic cometary process we've never encountered because interstellar objects are rare and we've barely studied any, then it's a tremendous scientific opportunity. A chance to expand our understanding of how matter behaves in extreme interstellar environments, how objects form in other stellar systems, what chemistry is possible under conditions we can't replicate in laboratories. That would be Nobel Prize-worthy science, career-defining discoveries, textbook rewriting revelations. But if it's something else, if the accumulation of anomalies can't be explained by exotic natural processes, if the acceleration really is controlled and purposeful, then we're facing questions humanity has asked for millennia but never had to answer with real data. Are we alone in the universe? And if not, what do we do when the others come calling? Not in science fiction, not in speculation, but right now, with an object currently moving through our solar system, exhibiting behavior we can't explain. China believes this question is urgent enough to issue a public warning. They believe the international community needs to be paying attention right now, not waiting for perfect data. NASA, for whatever reason, has chosen silence. They're waiting, analyzing, deliberating about what to say and when to say it. Who's right? That's not for me to judge. But I know which approach history tends to favor. Transparency, even when uncertain, usually ages better than silence. December will be crucial. When Atlas emerges from behind the sun, we'll have our answers. Or at least, we'll have new questions that are even more profound than the ones we're asking now. We'll see if the acceleration continues. We'll see if the patterns repeat. We'll see if there are any signals. And we'll finally know whether NASA's silence was cautious prudence or a missed opportunity to shape the conversation while they had the chance. But in the meantime, right now, the silence from NASA is becoming its own kind of answer. It's an answer that says, whatever we're looking at, it's significant enough that we don't know how to talk about it yet. And that might be the most important piece of information we have. So what do you think? Is China overreacting to ambiguous data, jumping to conclusions that careful science doesn't support? Is NASA hiding something, sitting on evidence that would change our understanding of our place in the universe? Or is this exactly how science should work? One agency raising flags early, while another demands certainty before speaking? Drop your thoughts in the comments below. I'm genuinely curious what you make of this, because honestly, I'm not sure what to think myself. And if you want to follow this story as it unfolds, because I promise you, December is going to be absolutely wild, hit that subscribe button and turn on notifications. Because whatever Atlas turns out to be, we're all about to find out together. And that might be the most exciting, terrifying, and important moment in human history. Or it might just be a really weird comet that teaches us something new about physics. Either way, I'll be here, watching the data, following the science, and trying to make sense of it all with you. See you in December.